Okay, the recording has started. The first topic I want to address is the natural phenomenon that gave birth to this theory, so to speak. I will focus the meeting on that. But why? Because it intersects with other subjects. So, my idea is not to explain the technical details of building a circuit. I'm going to explain the phenomenon itself and how it can be recreated. I will not go into subjects like the Q factor, inductance, and so on. Okay, so the first thing I want to show you is this video that Rick shared in his second book. There is something I didn't pay much attention to the first time I saw this video long ago. It was about a few details. First, this video explains very well why the common belief is false, that the ground only has negative electrostatic charge and the ionosphere only has positive charge. Basically, the first point to observe is this diagram here. Not only on the ground, but also in the clouds, we can have both electrostatic charges. And when these potential differentials meet each other, what we can see emerging from the middle of this potential is what Pecos Hang calls leaders. So what we are seeing here is basically, from the center of these two potentials, ionized lightning is emerging. It takes the easiest path to the highest part of the potential, trying to close the circuit, try to short circuit it. And this happens very often within the clouds. But sometimes it happens from the cloud to the ground. That is why it's named CG. The thing to keep in mind is, as I said at the beginning, this lightning has different charges in a specific order. That is why the first example shown here explains a negative CG, negative cloud to ground. As you can see, right here we have two potential differentials. But here, we have a smaller charge. That is why this leader isn't born in the middle of these two. Instead, it originates between these two. So, from here to here, what we see is the lightning trying to find the easiest path to short-circuit these potentials. However, something very particular about this negative CG is what we can see coming up from the ground, this upward positive leader. Is quite visible. What we notice if we use a high-speed camera shooting fast enough is exactly what you see down here, this small upward leader. But there is one picture in particular that really caught my attention. No, not that one. Rather, it is this one here. What we see is a mountain, an antenna, and this positive upward leader coming from the ground. It reaches more or less the same height as the antenna. Basically, what we have here are joules of energy. So, how can we use this energy? That is something I will try to answer later. But initially, we must keep in mind that this represents energy. This is useful energy. So what we have here is this negative electrostatic leader coming down from the cloud, trying to find the easiest path to short circuit or meet with this positive electrostatic leader, and then simply short-circuit this potential differential. We must remember that in nature, generally speaking, we have a state of balance. Then, due to cumulonimbus formation and other factors, we get this electrical imbalance. Following that, we have a gas, so to speak, because the leaders produce ionization of the air. And finally, we have this short-circuit light effect. But after this event, we return to a state of balance. Why? Why? Because the charges between these two potentials cancel each other out. So, after that cancellation, what we have is calm, repose, and balance. That is why it is common to hear people say, lightning never strikes twice in the same place. That is because the charges in that location are balanced again. Let's go back a little bit before the light effect occurs. What we can see in this diagram are two things. First, we have all this negative electrostatic charge here. And here, we have all this positive electrostatic charge. But in between, right here, we have this dielectric air separating these two potentials. Basically, what we have here is what Tom Bearden calls a dipole. Here is the negative, and here is the positive. So, when Tom Bearden talks about not killing the dipole, he is referring to this. I don't know about you, but many people, including myself when I studied Bearden long ago, thought that don't kill the dipole meant don't short-circuit the battery. From my current understanding, he was talking exactly about this structure. He meant we should not short-circuit these two dielectric potentials. I don't know if you are aware, but we can find something interesting in this manual here. The Likovsky multiple wave oscillator secrets revealed. They discussed the Tao-Shao theory. There was a Japanese researcher who explained exactly this, but in a different context. He was discussing how the spark gap is formed within a Likovsky machine, which is basically a quarter, well, not exactly a quarter, I'll explain later, a quarter-wave Tesla oscillator. Sorry, just a second. Basically, what Tao Shao explained with his theory is the same concept. From these two potential differentials, we get ionization of the air in between. And this ionization creates the space to form an electron avalanche. The electron avalanche is the equivalent to what we call the birth of the leader right here in the middle. I try to keep this idea in mind and started drawing some parallels. One thing that came to mind was this video by Plasma Channel where he made an electret. A lot of people don't know what an electret is. Basically, it is a dielectric material that conserves an electrostatic field. In this video, he explains how he manufactured this electret. In the first case, he used natural wax. While the wax was still warm, he placed it into this mold. And above and below it, he applied two electrostatic potentials, one positive, one negative. If I'm not mistaken, it was around 20 kilovolts. He left it until the dielectric cooled down. And what we see here is the highest point of this potential. It is detected at around 10 to 15 centimeters. Okay, Later, he shows a list of other dielectrics. On this list, the first one is Teflon. The fifth one is polyethylene. And the last one is wax, the one he already used. So he's going to repeat exactly the same process. And this is important. Exactly the same process with the same potential. But this time, he puts polyethylene inside. He just took a piece, warmed it up, and this is just a piece of steel. It is not a magnet. Just to clarify, he basically left it inside there for a while. Again, what we have here is this potential differential. In between, we have the air, the plastic, and so on. But remember this. When the dielectric barrier is broken or becomes low enough, we will see a luminous effect. And then balance returns. We must also keep in mind, this effect will continue as long as we keep producing this artificial imbalance. Okay, basically we are producing an artificial imbalance here. What happens next is that he extracts it from a mold. And what he detects now, using the same process, but with an improved dielectric, is a field at 2 feet of distance. Let's say it is around 4 to 6 times stronger. The electrostatic field is much stronger, simply due to the improvement of the dielectric. Okay, so with this in mind, I continued reading the Lakovsky book. One thing made me hesitate. It was a part of the document discussing the Coram brothers. They were explaining the process and the measurements on the primary coil and the secondary coil on the emitter antennas. In the Lakovsky machine, something that really caught my attention was this. Why is the primary not tight? It is separated by at least 2 millimeters. Each wire, each turn. And why doesn't the secondary do that? Exactly on the previous page, we find the explanation right here. What happens with the coils? When you have this very important parasitic capacitance in the coils. You can read this later, as the document is already shared. But what we see here is basically this. When electricity travels from here to here, meaning from the beginning to the end of the coil, the energy is traveling at the speed of light. But one must travel from here to here. The speed is around 100 to 105 times slower. And that is why. Why is this? It is exactly because of the parasitic capacitance accumulated on each turn of the coil. There are 2 documents mentioned here, Coram 1 and Coram 2. You can read the papers later. The names of the papers are at the end of the book. So basically what we have here is the knowledge that to obtain a well-made Tesla oscillator, so to speak, you must have parasitic capacitance at the end on your secondary coil. And how do we know we have a well-made Tesla coil? Well, if you check the video that I shared a long time ago, that was a check video found by Sandro. At the end of your Tesla coil, what you can find is this electrostatic effect. An electrostatic effect that Master Evo explained in his video posted near last Christmas. He called it the fringing effect. This is something well known. This is something well studied. I am not presenting this as a magic trick. But let's try to understand, again, how a quarter wave Tesla oscillator works. And also, so important, why the secondary coil in a quarter wave Tesla oscillator is grounded. To understand this well, the first thing we must keep in mind is the location of the node in an oscillator. Basically, if we have a regular oscillator circuit, okay, the node of that circuit will be exactly in the middle of the length of the first coil. Okay, this means if this cable is 10 centimeters, no matter the frequency, you will always have a node exactly at 5 centimeters. Knowing this, if we take a secondary coil attached to nothing, just a coil in the air, we can visualize the coil oscillating like this. In this case, due to the frequency we are using, this secondary coil is called a half-wave oscillator or two-quarter wave oscillator. Okay, the thing is if I move the inductor, my primary coil, just a little to the right or left, the node will no longer be in the middle. So if we find the node, let's say around here, we won't have the highest point of oscillation here, nor will we have it at this other point. Why? Because here we are past the quarter mark, and here we are before it. So, keeping this in mind, what we should try to do is ensure the node is always at the point we want. If we just erase this bottom part, practically speaking, we should connect the base of the secondary coil to the ground. In that way, we will always have a node at the base. And that represents why, when building a quarter wave Tesla oscillator, it is crucial to ground the base of the secondary coil. So the thing is, what we have to keep in mind, the Tesla quarter wave oscillator operates with the quarter wave section at the top. At this specific point, if it is working properly, we can see the fringing effect, this electrostatic effect, at the edge of the secondary coil. Sorry, give me just a second. That is why the Coram brothers talk about having 0 volts in the node of the secondary coil and a maximum voltage at the edge or end of this coil. But if we don't use the proper system, so to speak, what we get on this secondary and on this oscillator is basically this. In this case, the Czech experimenter put a probe in the air, and the oscilloscope is well grounded. They start reading the oscillations in the air coming from the Tesla coil. And what they measured was basically this graph. This oscillation starts from 0 and then increases until the electricity increases in the capacitors. And after that, it relaxes in a manner of speaking. But there is something pretty particular here. All these oscillations are going above or below 0. So these oscillations become positive and negative after a few seconds. The thing is, these oscillations are not monopolar. Why is this important? Well, if we want to harvest this energy coming from the ground, we know we need this monopolar imbalance. All this potential energy must be monopolar. And that is very important. In the same video, later on, they swap to this kind of Tesla oscillator on the primary with a spark gap and everything. And they start to do some measurements. What they found is basically, give me just a second. Let's see. I think I have it here. What we have basically is something like this. Okay. So the thing is, now our quarter wave Tesla oscillator goes above and below zero in the beginning. But later it gets polarized. And it just stays over or under the line. We will see later why it is also possible to go under zero. So now, this is monopolar. So during this period, if we ground the Tesla coil to the Earth, we should be able to drain some energy, to suck some energy from the ground. So, if what I'm saying is right, just a second. Okay, so if my theory is correct, we have the Tesla coil oscillator here, and we have a ground cable here, coming through a galvanometer, going through a capacitor with a safety spark gap, and then going to the tip of the secondary Tesla coil. And what we see is exactly this. Here we have a spark gap that is around 150 kilovolts, if I'm not mistaken. And here we have the cable coming from the ground through the galvanometer measuring positive 3 microamperes, going through the capacitors, and then closing the circuit or trying to balance our artificial imbalance. So, why is this so important? The safety spark gap? Well, we have a capacitor. Basically, if we have 150 kilovolts here, and our capacitor is rated for just 3 kilovolts, like this one, the spark gap will occur inside the capacitor and the dielectric will be destroyed. So to avoid that, what we do is protect our capacitor up to 1 kilovolt. That is why this spark gap is so thin. But if what I'm saying is correct, we have two ways to use this energy. The first one is putting more capacitors, not just in parallel, but also in series. Or we can put a load straight to the ground. One of the people who did that was Capanazza. Forget this part for now. We can discuss it later if you want. But let's keep this in mind. At this point, we have an artificial imbalance. And from the ground, I am receiving energy provided by the Earth, trying to compensate for my artificial imbalance. So, what Capanazza did here was put a load of 150 watts at 220 volts with a 230 volt safety spark gap. And as we can see here, it is not only working, it's working on demand. Because as I increase the imbalance, I can drain more energy from the ground. This is important to keep in mind, but why? Because if we look at Don Smith, for example, Don Smith was saying something pretty similar, but there was one little trick on his most famous circuit. This. The first part of his oscillator was just a regular oscillator, which was fine. That's not a problem. But the secondary coil of this circuit is not just a homemade secondary coil. It is this mini inductor coil with almost no parasitic capacitance at all. And that's not all. This coil is sold to military and government agencies, and so on. I don't expect you to remember, but a long time ago, I always said, I don't think we need unicorn blood to get energy from the ground. And this is exactly what I meant. He was basically telling people, you need this special capacitor made specially for me. They are damned special because they are damned expensive. And I know because I have some. He also claimed this coil was special because it was made for him. No, this coil was exactly the opposite of what Tesla was looking for in his circuit. So, we must remember that when we analyze Don Smith's circuit, the diagram might be correct. But what he shows is not always correct. Keeping this in mind, I will not focus on a specific circuit. I'm trying to focus on the phenomenon. How you reach that phenomenon is up to you. If you want to follow someone, follow them. If you want to create something from scratch, go ahead. So the thing is, moving ahead with this, we can see not only this part is important, but why? Because the measurement we have is positive 3 microamperes. But if we reduce the space between these two, let's say this spark gap, we can have a different measurement. And a Czech group did that test. They reduced the spark gap and obtained exactly the same effect, but in this case, they had minus 3 microamperes. What does it mean? Well, basically, it means that this dielectric circuit continues to close due to the potential differential. But the current going through the cable now is not positive anymore. It is negative. What we can see further in this video is if they keep reducing the distance between these 2 points, we get a closed circuit because the spark gap is there, but no current at all. That is important because one of the things we saw in Master Evo's last video was exactly this, the displacement current. He explained it very well, so I won't go into it, but I really recommend watching that video. It was launched, I think, on the 25th of December. So, here we can obtain positive current, negative current, or no current. Okay, but we can still have this dielectric voltage closing the circuit. So, what we have to keep in mind is why this is produced. Well, one thing the Czech guy explained is this concept of the longitudinal waves and how they are produced. There is a document I can share written by Thomas Barrett in 1991 where he explained why the Tesla oscillator is not a regular oscillator and how the secondary coil works with this radiant energy that is not accounted for in the Heaviside equations. But if you solve the if you solve Maxwell's equations using quaternion algebra, you will get this scalar field where the potential of the energy is infinite. So, since we're working with longitudinal waves, we must keep in mind that these waves are orthogonal to the coil producing them. Keeping that in mind, it makes sense to see this kind of effect at the end of the coil. Depending on the distance we use in our circuit, we will be making the spark gap interact with a node. A node exists between these two longitudinal waves. An antinode is exactly this part, the highest part of this gradient potential, or just the same positive or negative electrostatic field. That is why there is no current there. To clarify this, what we have here is basically what we call transversal current or waves, or Hertzian oscillation, the most commonly used. But when we work with longitudinal waves, what we have is exactly this. Node, antinode, node, antinode, node, and so on. The thing is, at the quarter point of this wave, we're going to have the highest potential. And again, at the next quarter of this wave, we will have the lowest potential. And that was exactly what Tesla was looking for. The way to reach that is to use the quarter wave Tesla oscillator or something similar. I'm going to show you later why I say something similar. As we said in the beginning, the Likovsky machine was a Tesla coil oscillator. If we keep that in mind, what we see here is the Likovsky machine with its antennas. Basically, what we have here is exactly this. These oscillators have coils or antennas, whatever you call them, connected in opposite ways, while one antenna is at the highest positive potential. The other one is at the lowest potential. So basically, and I will explain in a minute why it's not exactly what I'm saying, but it works that way. Basically, we have this. If we darken the image, we can see again a quarter and a quarter. How does a Likovsky machine get calibrated? Well, to calibrate a Likovsky machine, you must put a fluorescent tube between the antennas. Why is this important? When the tube glows, that is exactly the midpoint where these two antennas are working. And why does the tube glow at the midpoint? Exactly for the reasons we discussed before. What you have here are leaders coming from the ionized air, or the ionized dielectric between these two potentials. In this case, the gas inside the tube is a better conductor than the air. That is why it starts to glow. So basically, what a Likovsky machine is trying to do, from my understanding, is to harvest this energy coming from the midpoint, coming from the center of the dielectric, or in other words, coming from the nodes. Okay, it comes from here to the antennas. One of the considerations during the construction of the Likovsky machines was if I have two quarter-wave Tesla oscillators, what happens? As soon as I put a person or patient right between these two antennas, many of these electrical arcs and flashes come out from the person and go to the antennas. We don't want that. We want a reduced effect. But we want exactly this process. So how do we do that? We do that using not a quarter-wave Tesla oscillator. but a 1/12th Tesla oscillator. Again, we are working with the same process, with the same electrostatic accumulation. Okay, but at a lower potential. Actually, what you find in the manual is that the Lakovsky machine worked with 3 different levels. Probably. And again, from my understanding, this is because it is not the same to treat a heavy person like me, or to treat a woman or a child. So the dielectric properties between the antennas vary depending on who is in between. Okay, so when I talked about this, I said there is not only one way to reach this. Because one of the things we see in the check video is exactly this. If I am not mistaken, this kind of oscillator is called the Hercules oscillator. And it is, again, a 2/4 wave oscillator. Basically, they do exactly what we are watching right now. They place 2 probes in the air to try to measure what is going on at the end of these 2 coils. What we can see here, with this circuit again, a regular Tesla oscillator, so to speak, is this. Again, what we see here is that the oscillations at the beginning are pretty normal, so to speak. What does it mean? It means, in this case, each square is 20 microseconds. So for around 12 microseconds, the coil is working normally. But after that, due to parasitic capacitance, the coil gets polarized. And from the inductor to one side, and from the inductor to the other side, we get opposite polarization. So on the left side, we will have this positive monopolar, and on the right side, we will have this negative monopolar. Here we see exactly the same, just with one probe. This is the regular oscillator, just the coil. Basically, what we have is exactly this. It is this electrostatic potential accumulating on each side of the coil. When I reached this point, I started talking with Master Evo, who told me, yes, you are seeing only 1/4 of the picture. And I asked, okay, so what else? We talked about exactly this concept. If we take these 2 electrostatic potentials, and we take this coil, and we put some plates in between, but also with a dielectric in between, what we will have here is a capacitor. And not just a capacitor. Why do I want to focus on this? Because here, we have a regular capacitor in a way. But as we saw at the beginning of this talk, what we will have in that dielectric is an electret. And not only that, we must keep in mind that as long as we have a coil and a capacitor, what we have is an oscillator. When this coil is not active, because we saw this is not a constant line, this is not a DC voltage, it is a polarized oscillation. As soon as the excitation stops, all the energy will try to travel to the capacitor and start to auto-oscillate. But remember, this is not a regular oscillator. Why? Because this is not a regular capacitor. It is an electret, and we saw that the electret conserves an electrostatic field. That electrostatic field will feed these plates, again on each oscillation. In the beginning, I really thought I was crazy until someone shared this media article from Aaron Murakami with me, where he explained exactly the same thing, but with the Benitez circuit. Basically, he said this. I found that by charging the capacitors with high voltage pulses, whether it was 100V or 1000V, it changed the properties in the capacitor to act like an electret. That means we were working with a kind of battery. So, this is just a concept, but I'm not the only one who reached this conclusion. Yes, I'm probably one of the last ones, but I'm not the only one who thinks this. Also, Master Evo asked me, well, what if? Give me just a second. I want to phrase it correctly. What if you put a ground cable or a ground plate here? Well, from the ground to one plate, you will have one kind of current. And from the ground to the other plate, you will have a different kind of current. Why do I say this? As we saw before in the check video, the current coming from the ground can be positive or negative. It is not the first time I've heard about this. I am not the only one discussing this cold energy. It is not entropic, it is negentropic. There is no heat, it is cold. It is not chaotic, it is organized. I'm not just throwing words around. I will try to go further into this. But before going further, does anyone want to ask something? Okay, I'll take that as a no. Let's move on. I started talking about this with many different people, including a quantum physicist. He was quite impressive, not just because of this topic, but because of what he concluded later. Another thing we have to keep in mind is the Testatica machine circuit made by the Mathernitha community in Switzerland. It was based on something similar. I'm not saying exactly this, but again, electrostatic charge going through these kinds of Leyden jars and so on. They start from an electrostatic charge. That is the method, from my understanding, and probably I'm not alone in this, to get free, useful energy from the ground. We not only need to get an electrostatic monopolar field, we also need to move it to produce this displacement current. An interesting mention, if I'm not mistaken, regarding electrets, Tesla mentions that someone was rotating them like magnets in a generator, but with electrets. And this person created a magnetic field. So, transversal current and displacement current are similar. Not identical, but pretty similar. The difference is which known law applies to each one. I kept talking with people, and some told me, if what you say is right, then what they call electroculture or electricity in agriculture makes a lot of sense. Let's dive into this a little bit. Let's say we have the ground with some energy and the atmosphere with some energy. We know that not all fields are the same, but there is a concentration of energy in different areas. Let's say I plant my lettuce in the ground. In my mind, this energy comes from the ground, trying to balance the produced imbalance. It could be higher or lower, it doesn't matter. It is just an imbalance. And that energy comes through the plant. Why? Because the dielectricity of the plant is lower than that of the air. That is why Tesla explained in his patents that he didn't want to use the air. He wanted to float balloons. I don't remember the exact distance, but it was around 20 kilometers because the dielectricity of the air becomes lower at that point. So, if we have this lettuce reducing the dielectric resistance, the energy will flow through it. If what I am saying is correct, putting an electric here close to my plant should make my plant grow stronger, faster, or bigger. Why? Because my electrode is positive. The energy coming from the ground is negative. Why? Because as we saw in the beginning, the energy always goes to the opposite side. So if the ground is here and my electorate is positive, the energy coming from the center is negative. Based on what we saw before, this current is negative. And we know that this negative current, or cold energy, is organized. The funny part was when I started reading this in different books. For example, these two books I already shared in the group. The first one is electroculture, and the second one is electricity in agriculture. I found these 2 pages I showed before. One was to improve the growth of a tree, but the second one was this. This is basically a mesh. Sorry, let me flip the image. It will be much easier. Okay, this is basically a mesh coming from this kind of circuit. This circuit has one terminal connected to the mesh and the other going to the ground. What made me hesitate was, where have I seen this before? I saw this somewhere. Well, I remembered. It was exactly here. This is the book I already shared with you. And this is from Tesla's conference in 1891. I don't remember exactly, but he explains why he works with high frequency, high voltage, and so on. He explains the tests he was doing with these secondary coils. On all these secondary coils, we have different kinds of effects and tests. But we also find something here that really caught my attention the first time. This concept. You have a primary here. This is the secondary. And here are the two terminals. One of the concepts I really liked was, give me just a second. This one, this is a primary and a secondary, but the secondary goes through a lamp and then to a plate. It really made me think, doesn't this look like one of Don Smith's designs? With the secondary through a lamp, like Don Smith's Mexican patent? Well, I'm not going to get into that. My understanding is, yes, it is. When it comes to agriculture, we get exactly what I expected. Let me continue with this. I know I have it here. Yes, someone gave me this book by Alexander Gurevich. Alexander Gurevich was a Russian scientist. In the 1950s, he proposed an artificial ionosphere near the ground to improve communications and explore ways of working with this electrostatic energy. He also had this book discussing nonlinear phenomena in the ionosphere. When we look at the Barrett document I mentioned earlier, one of the characteristic things Barrett mentions regarding the Tesla oscillator is, again, this nonlinear effect that allows this oscillator to reach that radiant potential. So, going ahead with the check video, I remember a specific part of the video where they're talking about, give me just 2 seconds, when they were talking about the effect produced on a metallic. Not this one. I think it was around here. No. Yeah. Okay. One of the tests they did was placing this steel cube exactly aligned with the upper end of the secondary coil. And then they just leave it there for a minute. Let's see what happens. This is the primary Tesla oscillator. Basically, he disconnects the circuit. He takes this cable coming from the ground through a neon bulb, and he touches this piece of steel. If what I said was correct, we have an accumulated electrostatic charge on this cube. So the ground is going to send the energy needed to compensate for this balance. And there it is. There's some lightning. We might say, okay, I drained the energy from that steel, so the imbalance is finished. No, nope. After a few seconds, he repeats the test. And again, the same effect. He waits some seconds, repeats the test, and the same effect occurs. Now, we can see he is just short-circuiting it. Once again, he is killing the dipole directly with the cable. And after a few seconds, there it is. Basically, what happens here is that this is not a regular piece of steel anymore. This piece of steel has been restructured, so to speak, due to the electrostatic energy. Master Evo mentioned that the wood of his desk had become charged with electrostatic electricity. He could feel that electrostatic charge on his arm hairs. So, again, when we interact with this kind of energy, some non-normal effects appear. One thing that came to my mind was, okay, so the energy is coming from somewhere. This energy was short-circuited. The energy was drained, but after a few seconds, it recharged again. With some people from different fields, one of the questions we asked was, is there a structure in the reality surrounding us that responds to geometry? One thing we see is the weirdest effect that happens when working with pyramids. And not just any pyramid, pyramids that are well made, with the right angles and so on. This video is one of my favorites. Here we see mangoes purchased at the same store. Let's say from the same production batch. We have two and two. What we observe after a few days is that the mangoes located outside the pyramid rotted before the mangoes inside. It's not the only case I've heard about. Unfortunately, I don't have a picture right now. I promise to look for them in the future. But I discussed an experiment with this quantum physicist regarding neutrinos produced inside a pyramid. One common test is to place a glass of water inside the pyramid and then put that water in the freezer. You perform this test with one glass outside and the other inside the pyramid. And we see a different freezing pattern in the glass that was inside the pyramid. You can search for information about this. It has been measured and verified that neutrinos are formed inside a pyramid. And it isn't just one kind of pyramid. People have been conducting these tests for a long time with cardboard pyramids. The important thing is to use the right angle. Moving on, I shared this patent in the group a long time ago. It was related to this. We have a pyramid here on the ground. Basically, this circuit is similar to what we discussed before. I have a pyramid producing an imbalance. And the bottom of my circuit is well grounded. Again, we're talking about draining energy from the ground based on an imbalance. Something that really caught my attention was a video a guy shared with me. I didn't know about this. It was this one. Corrado Malanga is an Italian researcher who worked on this latest research. Give me a second. I'm trying to find the name of this research. I don't recall it right now. Yes, the Coffer Project. KHAFRE project, which basically talks about these columns or these oscillators. Sorry, these inductors, going from the pyramid to the water. What really caught my attention was, well, maybe I'm cherry picking. But from my point of view, it is not so different. The difference is that this patent was proposed in 2011. So we were talking around 15 years ago. And this meeting was in June of last year. Continuing with this, I talked about this with other people who work with crystals. I started thinking, I have a primary oscillator which is regular, and I have my secondary coil that is a nonlinear oscillator. I thought, if I want to improve this circuit, how can I do it? In my mind, if the primary is a regular high voltage oscillator, I don't know much about crystals, but I know that while you can get a high Q factor on a regular LC circuit, if a crystal is used at the appropriate frequency, you can obtain approximately 15 times more. The bandwidth is tightened, but the Q factor becomes, depending on how well you do it, around 15 times higher. So I asked myself, what is this for? I try to remember how a crystal is made for this circuit. One thing we find on the internet is this. This is not the most common, but this is a crystal oscillator. What we see here is basically two plates and a dielectric in between, a crystal dielectric. A dielectric that has the particularity of being piezoelectric. So every time I apply voltage to this dielectric, it responds with an electrostatic and piezoelectric effect. It starts to make sense for me to say, maybe it's not crazy to use a crystal in this circuit as a dielectric. Of course, it is a lot of work. I'm just talking about the concept. We can use Teflon if we want a great electret. But conceptually, a crystal is not so crazy. Somebody shared with me this old man, a famous YouTuber related to orgonite. What he does is basically this. To my mind, it makes a lot of sense. Knowing what I know, I would say, this makes more sense if, again, I have this secondary coil made with a lot of parasitic capacitance. And at the end, I should have this fringing effect. But again, varnished or coated cable, not this one. This one in particular. Here you have some parasitic capacitance. The person who shared this told me, don't forget the orgonite. It is what you use when you make a cloudbuster. It makes sense to say, what is basically a cloudbuster? A cloudbuster is this kind of crystal with copper pipes and so on. But basically, it is an antenna or a better dielectric than air, placed on the ground, trying to compensate for an imbalance. It makes sense to me to say, I use this directed antenna to cancel the cumulus in that cloud and erase or eliminate that cloud. Another topic I discussed with another guy. Oh, sorry. I'll get to that later. One subject I discussed was, I don't know if you know, but sound is also a longitudinal wave. I said, okay, then it's not so crazy to think. What if I want to produce levitation using sound? Because it is well studied. As long as you have this node, antinode, node, antinode pattern. If you interact with it in the right way, you can reach a certain level of levitation, just like acoustic levitation. That reminds me of Grabenikov's work, dealing with how Egyptian beetles fly. I don't remember the exact name, sorry. Aerodynamically speaking, there is no way these insects should fly. The wings are too weak. One thing he found inside this part of the wing, this shield, is a nanostructure that reflects the longitudinal waves between these 2 points. Basically, what we have here is a standing wave produced by the reflection of a longitudinal wave. When I discussed this with a quantum physicist, he said, this makes a lot of sense if we recall an article a colleague wrote. It is basically this paper. Gravity as a plastic distortion of the Lorentz vacuum. If you want to have fun and not be bored during a long weekend, here are 164 pages of beautiful mathematics explaining why gravity is not what we think it is. The funny part is that upon presentation of this paper, Virginia Belma Fernandez, who is Argentinian, received an invitation from two guys in black suits to not talk about this anymore because it is a military matter. That is why Virginia doesn't want to discuss this anymore. Going further with this, it is funny to find patents like this one talking about flying machines. The name is Rotating Electrostatic Propulsion System. Pretty curious. Let's talk about this. When I was talking with Master Evo, he shared this image, the result of an experiment by the Russian guy, who basically changed the position of the ground in a regular oscillator. One thing he noticed is that with the ground at the base, taking into account the diode, we get a regular oscillation going first to the positive side. keeping the probe in the same position. If we do the opposite, the oscillation goes negative. But if we remove the ground from this oscillator, what we have is basically this. This negative pulse that Tom Bearden talked a lot about. This is probably one of the simplest ways to reach this monopolar imbalance we are looking for. Again, I'm just saying probably. Master Evo is building his own system right now. He is working with this double oscillator and the displacement current inside this triple coil. It is quite complex, but from what we discussed, it seems to be what works best. One healthy thing to keep in mind is this video that I always mention, showing the two sides of the concept. Here we have a Wimshurst generator. What this Czech guy did was measure the radiation with a Geiger counter at the terminals of this Wimshurst generator. And what they measured was around 44 on the Geiger counter. 44 units. This level of radiation is similar to what you can find in Chernobyl. So, as much as I say one thing, I also want to say another. We must take into account that we are dielectric. For this reason, when working with this type of electrostatic field, we can easily become charged. And that will probably produce a lot of electrical imbalance in our bodies. One of the most important things we can do for our health, if we decide to dive into this, is to ground ourselves for at least 15 minutes after finishing tests. Go to the ground to compensate for the imbalance produced in our body. Because generally, we are not barefoot. We wear shoes, Crocs, or whatever. And all the energy gets accumulated in our body. Rick also mentioned long ago that someone had health complications. And Evo mentioned it to me as well. So, I won't mention this. It is also probable that what we are watching here is just a misreading. I talked with an Italian guy who works with Geiger counters. The first thing he told me was, keep in mind that these Geiger counters are toys. This is not a professional one. What these toys have inside is a vacuum tube. A vacuum tube to measure radiation in the area. Why do I mention this? Because here, 0.20 is nothing to call your attention. But as the guy moves the Geiger, you will see it starts to jump up. So the thing is, it is probably because the vacuum tube inside this toy is going crazy. And not because the radiation is real. But we have to keep in mind, when we work with this, we will probably be charged with this energy. Two last things to say to finish. The first one is this video. This is a Russian video that talks about the importance of geometry in resonance circuits. What they show in this video from 94-95 is that it is possible to reach a Q factor over 1 with a well-made structure, so to speak. This video is important for my understanding, not just because they talk about structure, but also because they talk about how it is possible to use this structure to accumulate energy. This isn't so crazy if you start researching technologies from 1850 and earlier. But everything people are saying about Tartaria might not be so crazy to take into consideration. If we think of a church as a structure that swings freely in front of a bell that produces oscillations when it rings, it is not so crazy if we have the right structure. And just as a bonus, and for fun, there's a patent from 2003 that talked about opening wormholes using this kind of technology. We can see here how they talk about this negative pulse. If you want to have some fun, you can look into it. So, right now, I think that is all I can share from my point of view. What I'm doing right now is finishing reading some books. I want to start with the Colorado Springs notes before moving ahead, because I still have some gaps that don't explain certain things, but I think this is pretty consistent.